Thank you for coming back to Learning Image Analysis. Our lesson today is Iterative Refinement of a Segmentation. We have two images, both of which we've handled before. On the left is two-phase titanium. We have the dark alpha phase and the bright beta phase. And on the right we have colonies of cells. And in both of these, our previous segmentations had a few errors that I want to address. So we're going to fix some of these mistakes, make the end result better, and make the end measurements better as well. So our learning objectives: first, identifying errors in your segmentation. We'll just look and see what the errors are, and then decide whether or not they even need to be addressed. Then we've got two different ways that we'll use to iteratively improve our segmentations. On the titanium image, we'll use a mask and a region of interest to make our area fraction measurement more accurate. And then on our cell colonies image, we'll look at the differences between the centers of our features and the edges of the features, and how sometimes you have to do multiple stages of segmentation in order to get both of them identified properly. Here we have our two-phase titanium image and recipe. As you remember, we had two different ways of segmenting, one based on the adaptive threshold, the other based on our flattened background. We're only going to deal with one of these today, since this segmentation isn't the actual point of the lesson. The point of the lesson is to fix errors caused by this dark piece here and this bright piece here, which are found as alpha and beta when they shouldn't be. So we could say that this piece here really is alpha underneath, and so assign this to beta and somehow figure out that this is alpha here and beta here and alpha here, and try to assign what's underneath this black piece of dirt to the structure. But there's a lot of guesswork in that, and really it's simpler to just exclude these erroneous features entirely. You want to remove them from the segmentation, but you also want to remove them from the area fraction measurement, because remember, this is a percent of the entire image as alpha or beta. So we don't want to do relative to the entire image. We want to do to the image with the same pieces removed from it. That way we have an accurate percent measurement. So to accomplish this, we'll start with our noise reduced image and select these dark and bright features. And so the simplest way to do that here, what I'm going to do, because we want both dark and bright, is do a range threshold where I select all the stuff in the middle and then just invert. It's takes less processing time to do that one range threshold rather than a bright threshold, add that to a dark threshold. Much easier to just invert. So if I have here, find a good number for our bright threshold here. We want to get this piece segmented while still maintaining very small amounts of other stuff here, really bright beta. So this value right about here looks to have a significant amount of this identified, and all the really bright beta is significantly smaller. And then if I do the same for this this dark piece, right, we have something about that size. Okay. And we'll accept. Now with our range threshold, let's reject these small holes here. So we want to do size of, let's see what 5 looks like. Looks like it's removed pretty much everything. Okay. We have this thing here, which really should be removed. What else? Another one here. Alright, looks like the only things that are found now are things that we legitimately want to remove. So let's erode. Say a depth of 2. That looks to get most of it. And same over here. Okay, so this is going to be our mask. We have a selection of everything but these features that we don't want measured. So if we set this as a companion image, just like that, that'll save it away. So when we do our area fraction measurement, we can measure relative to the companion image. Okay. Now, let's call back our noise reduced image for the actual adaptive threshold processing. And here we have our alpha, which has this piece found, and we'll just intersect. Just like that. Now we can see we didn't quite erode enough. So let's make that 3. Okay, now the entire piece is gone. And move our layer. And that's our corrected alpha selection. And we'll do the same thing for the beta. Here, we'll have to intersect with our mask, just like so. And all these errors are removed. And now, when we perform our area fraction measurement, on all the images, you can see we're still adding up to 100% here, even though there's chunks that are missing from both layers, because we're measuring relative to this companion image that we set. And that's all there is to it. So let's switch now to our colonies. We have a recipe, and load back in this recipe that we used. In this image, the specific errors that I'm looking to remove are pieces that are concave on the edge of a colony. So these are being found as cells here. And why is that? Well, if you remember back, we had 2 different methods of finding the proper boundaries of these colonies. First was a bright texture, which of course finds bright concave features. We were okay with that because these were going to get removed with our dark texture. You see the dark texture doesn't find this. So where did this come from? And why did they end up in our final cells segmentation? Well, it comes from the manipulations we did after we did our thresholding. A morphological closing, which is what you call a dilation followed by an erosion, has a tendency to fill in tight concave pieces like this. And that's why we end up finding a cell here. I don't remember if we find a cell here or not, but throughout these colonies, there are places where this selection is made inappropriately. Okay, this here. Okay, and there's a few more, including this tiny little piece, which doesn't fall into a cell count because it's part of this one feature. But this pretty significant piece, this piece here, this one here is correct, but this here shouldn't be found. So how do we fix this? Well, our dilation and erosion was a little bit too strong, our closing. But it needed to be this strong in order to fill in all this stuff in the center. Right? We needed to dilate that much so that we could then fill holes and erode away. So what we can do here is segment the centers of these colonies separately from the edges. The purpose of this closing was to fill in the centers, but we can have a different couple of steps which set these edges precisely where they need to be. So we have our center here, and we'll erode away just like so, say about that much, so that we're not finding any of these concave boundaries. Maybe a little bit more. Now, we can then find these edges precisely using this same selection that we had before. So if I take this, save it away, have this, set it as a companion, and add it to our precise edge selection, and we have something like this, where the centers are filled in, mostly, and our edge has a nice tight boundary. Now we can do some gentler cleaning to fill in these tiny holes without obliterating these corners. So say I dilate just by 1, not by the 5 or 6 that we did before. Right, so I dilated by 1, right, and then I'll fill in a little bit of this tight inset with our smart dilation. Excuse me, I'm on the wrong step. Here. We'll fill in with our smart dilation. Threshold of 5, about like so. Right, now we have a much tighter selection that follows these concave edges better. And we can erode away. Erode uniform 3. So we've eroded by 3. And we'll do a tiny little piece like that. It needs to be cleaned up. Well, actually, that will all get cleaned up here in our subsequent cleanup steps that we had before. So if I enable, and we'll look and see what our cells look like now. Much better. We don't have this cell found here on this concave border, This whole boundary looks really nice. Yep, the same should be true up here. One error there still, but much better. I don't see nearly as much. And if we wanted to have a look to compare what the before and after looked like, let me set this as reference image. And now remove what we just added here, here to here. You can see all the pieces that were fixed. These cells here, this here, several over here. All these that are now no longer inappropriately found. Okay. And remember, our concept for motivating this particular set of cleaning operations was differentiating the center of the feature from the outside of the feature. We had an aggressive closing operation in order to fill in the centers. Then we eroded it away, added our tight edges back, and did a more gentle cleaning in order to get the edge found appropriately. And now we can do our measurements, and we have about 100 less cells. So that actually ended up being kind of significant. And that's it for today. Next time, we'll continue with iterative refinement of a segmentation.